At the beginning of the design phase of our robot, we knew that we wanted to be able to pick up 3 tennis balls and put them on the board in a single trip. We began with this idea using an arm to place tennis balls into a hopper and then pull them out of the hopper and stick them onto the board. But eventually we realized this would be quite complex and it may not actually save time. So we moved on to this new forklift idea. This new style hopper can pick up 3 balls in a single shovel, raise the hopper, and stick them onto the board.
After deciding that we wanted to use a 3-ball scoop, we had to figure out how to lift the scoop. At first, we were leaning towards a forklift system, kind of like the one shown here. Then we could lift the scoop to any height. A forklift would give us flexibility, but would also be pretty easy to make using gears and a belt, right? No. We were derailed by the fact that G9 is only stocked with timing belts, which are meant for wheel treads and don't match with the gears provided. We would either have to make our own belt or make our own gear, or switch to another system entirely. So, of course, we switched to another system entirely. We decided on a pulley system because it seemed even more straightforward than the forklift system. Fishing wires attached to the scoop, hung over 2 towers, and then connected to a servo motor that reels the scoop up or down.
So to move the forklift up and down, we had a few designs. Some included belts, some included moving gears, and then we eventually decided on this track system. So initially we were going to cut Delrin pieces into towers with dovetails in the back here, so this can slide without any moment. Moment's the right word, right? So we were initially going to cut Delrin pieces with the dovetailing in the back here, but then we realized that we had these metal square pieces with holes, so all we had to do was mill a whole piece down here, and then include dovetails on the 3D printed part, and it works perfectly. Everything is perfect.
All that was left to do was laser cut the servo motor mount and make sure that we adapted the scoop according to the new design. All in all, it turned out nicely.
The robot is pretty simple, but it's probably best that it's simple because it allows for a really sturdy design. It's quite large and quite wide, which makes it barely fit within the box, but because of that, it distributes the forces around the entire base. So we kept the base the size it was, and it's pretty large because we wanted to distribute the center of mass, so we would have the gearbox and the servos all towards the back, which would counterbalance the tennis balls that would be placed in the forklift. During our design and manufacturing process, we were constantly reevaluating designs and remaking parts. We definitely learned that it's more effective to invest a lot of time in a thoughtful design rather than build things really quickly and having to redesign them over and over again. Nonetheless, the trial and error process that we've been through with our robot was definitely beneficial in helping us learn how to design and build everything from a pulley system to silicone molded